Now we are going to solve the triangle using the law of sines. Remember, we use this when the triangle is a non-right triangle. For this first question, I am going to label A, B, and C so that you can see that A is 46, and then the side A, which would be right across, is 34, and side B is 25. So the law of sines says that I can set up the sine of an angle divided by the sine across from it, and it will be proportional to another angle, the sine of the angle divided by the side across from that. So we can see here that I have angle A and side A. Another easy way to do this, which I have my students do, is write out the three angles and then write out the three sides. So capital A is angles and lowercase a is sides. And I'm going to write in the information that I have. So I know that side A, or angle A, is 46 degrees and side A is 34. So if you set it up this way, it's very easy to see that I know angle A and side A across from it. I don't know angle B, but I know side B. So this only asked me to solve for angle B. So to do that, I'm going to set up a law of sines, okay? So the sine, I'm going to set up a proportion using the law of sines. The sine of 46 divided by 34, because that's the sine of A over little a, and then we've got the sine of big B, which is the angle B, over little b, which is 25. To solve this, I'm going to cross multiply. So we get 25 times the sine of 46 equals, and then we cross multiply the other way, 34 times the sine of b. Now I want to get the sine of b by itself, so I'm going to divide by 34. And then we get the sine of b equals, so I'm putting this in the calculator, 34 times the sine of, 25 times the sine of 46. And we're dividing that by 34. And we get 0.529. We always round to 3 decimal places when we round. To solve for this angle, I push the second button, which turns me into an inverse sine, 0.529. Second sign, second answer. We get 31.933. So 31.933 would be our angle B. Okay. All right. So do I need to check for a second triangle? Maybe. Because it only gave us the angle B, I probably wouldn't on this one because we already know what that is. If I did solve for another one, I would do the 180 test. So I would take that angle that I solved for, I would subtract from 180. Okay, so 180 minus 31.933, and we get 148.067. And we already know angle A is 46. So if I add those up together, I get 194, and that's greater than 180, so I know that that will not work. Okay, so there's not a second triangle possible on this problem. We will have to check that on our question B as well, okay? All right, so now we're going to do the same thing, A, B, C, A, B, C, and then we're going to have a second. So I put a little 2 right here to show that this is a possible second triangle. Very likely that it could have one, okay? So the angle B is 35 degrees. That's going to be the same on both of these possible triangles, okay? These are our possible 2 triangles. And side B is 29, and it's still 29 here, 34 and 34. So the first thing I'm going to solve for is this angle C. So we're going to set that up doing the sine of 35 divided by 29. I set that equal to the sine of angle C divided by 34, cross multiply. we're going to set those two things equal to each other. And then we're going to divide by 29 to get that sign by itself. And then I'm going to do the inverse sign of this whole thing. Okay, so if I put that in the calculator, I'm going to do 34 times the sine of 35. And then I'm dividing by 29. And then I'm doing second sign, second answer. And I get 42.258. Okay, so right here I got 42.258. Okay, so I got my first angle. I'm going to subtract 42.258 to do my test. So 180 minus 42.258. And we get 137. So if there is a second angle, I'm going to scoot this over just a little bit. If there was a second angle C, it would be 137.742. Okay. These are my second ones. So if I add these two up, 35, and I add that together, I get 172.742. So I actually can have a third angle here if I minus 180. If I do 180 minus 172.742, I get 7.258. Okay, so if you add these three angles together, you're going to get 180. And then if I do the same thing here and I subtract those two angles, or if I add those up and subtract from 180, however you like to do that, then you get 102.742. So that's going to be this one, 102.742. And if I add these three angles together, I still get 180. So we do have the case where this one is going to have two triangles. And if you miss that second triangle on this, then you're not able to get that fourth point, okay? So make sure that you understand how to check for that second triangle by subtracting the first one you solve for from 180 and then going through and solving the rest of the problem if it works. All right, now my final thing I have to do is I have to solve for this A1, and I have to solve for this A2. So I have two more problems to do. I was given the sine of 35, so I'm going to keep using that, okay? And I don't know what that is, okay? And then my other problem is going to be the sine of 35 over 29 is going to equal the sine of 7.258 divided by A2. Okay, so we've got two problems to solve here. So A equals 29 times the sine of 102.742 divided by the sine of 35. And this one is cross multiplying 29 times the sine of 7.258, so that's your acute angle, divided by the sine of 35, and that will give me my other angle, okay? So when we enter that in the calculator, we get A1 is 49.315, and over here we get A2 is 6.388. Okay, so we've got our two triangles. They both have A, B, and C. And the ones that we solved for was little a, and those two. And then we solved this one, and this one. Okay?